Hello everyone, this is the last quiz. Let's see that how should we solve the problems on this quiz. Okay, so first let's look at question 1. So this problem tests a basic property about the power functions. If we look at the left-hand side, which is this, all right, so you see here, this is the sum of 6 to the x, so which is 6 times 6 to the x. All right, so this one equals, because here the power is 1, so this is 6 to the 1 plus x, right? So equals the right-hand side, that's 6 to 15. So from here we deduce 1 plus x equals 15, so x is 14. All right, so here the main point is we use this basic property of a power function. So the general rule is this. So this is the general rule. Okay, so if I number a to the power n times a to the power n, this equals a to the power n plus n. This is the general rule, and it works for essentially it works for all real numbers n and n. But if we think of the basic scenario, both n and n, they are part of integers. Then you can look at, let's say, the basic case, which is n and n. They are positive integers, right? So for this we have, okay, so a to the n, this is just a times n, the a times a, we have n, and then you multiply by a to the n, and this is a times a, we have n, right? So if you multiply together, you see in total you get the multiplication of n plus n a, right? So you get, okay, so a times a, all the way to a, and this is n plus n, which by definition is a to the n plus n, right? All right, so remember this. So this is a basic rule of a power function. All right, now let's look at problem number 2. So the problem says there are two numbers. If one increases by 1 and the other decreases by 1, then their product increases by 2020. Next, if we switch decrease and increase, the question is, all right, how much does the product decrease? Okay, so for this problem, we are going to use a little algebra. So solution, algebra. So step 1, let's assume that the two numbers are x and y, right? Well, one increased by 1 and the other one decreased by 1. Since due to the symmetry, let's say at first we x increased by 1 and y decreased by 1. Okay? So then we have x increased by 1, so we get x plus 1. And y decreased by 1, so we get is y minus 1. And by this, we get a product increased by 2020. So this implies x plus 1 times y minus 1 minus x times y increase by 2020, right? All right, so we can simplify a little bit from here. So what we get, we can write by the distribution rule, we can write out, so x times y, x times negative 1, 1 times y, 1 times negative 1, right? So this is x times y minus x plus y minus 1 minus x times y equals 2020. All right, so then they can, xy, x and y, they cancel with each other. So immediately we deduce y minus x, so negative 1, you move to the right-hand side. So this is 2021, so this is what we have. All right, so this tells us y is larger and it's 2020 more than x. Now, what do we want? So step 2 is we switch the decrease and increase. We have x, y. So this time x is decreased by 1, so it's x minus 1. And y is increased by 1, so we get this y plus 1. And the question is, this time we expect the product to decrease. So the question, how much it is decreased? So xy minus, this is x minus 1 and times y plus 1 equals how much, right? Okay, so what do we do is, again, let's use the distribution rule. So this equals x times y minus, again, x times y, x times 1, and negative 1 times y, 1 times y. Okay, so we have x times y, x plus x minus y minus 1, all right? Now, we are going to get rid of the bracket. But be careful, when if there's a negative sign in front of the bracket, when we remove the bracket, we need to change sign, whatever is inside, right? Okay, so we need to change the sign. So from here, this equals, so xy minus xy minus x plus y, and this plus 1, right? Okay, so again, so here xy, they cancel with each other. So what we get is y minus x plus 1. Okay, so, but we already know what is y minus x is right here. So we get this guy equals 2021, and you add the one more 1, so this equals 2022, right? Okay, so if for the second operation, after the second operation, the product is decreased by 2022. Okay. Now let's look at problem number 3. So problem number 3 is a distance and time graph. So this one shows the trip of Tom. So he left his home and he has visited some friends, and he went back home and take some rest. Okay, so it's the description of the whole trip. Now, what's the question? The question is, from this picture, can we tell the number of friends that he has visited, right? He has stopped the play, whatever you put it. Now you see, this just means if you look at this from the graph, this basically means he stops at some place for a little bit, for a while. So what he should have is he should have a flat piece. Flat piece in the sense the distance does not change, but the time changes because he stayed for a while. And the distance has to be positive, right? Because it has to be away from his home. So based on that, we have 2 pieces, right? So this is piece, this is second one. So this is the house 1, and this is the house 2, right? So you see clearly that he has visited 2 houses. Now, if you look at this one, that's another flat piece. But for this piece, because the distance 0, just means after he has visited house 1, he went back home and stayed, and let's say take a rest for a while. So this is he stayed at home, right? You stay at home. So if you combine all those information together, we get the total number of houses that he has stopped to play is 2. Yeah, just these 2 flat pieces. All right. Okay. Now let's look at problem number 4. So problem number 4, we have, so this is a coordinate plane, right? We have a triangle that is on the first quadrant. Then we do 2 movements. Movement 1 is reflect with, okay, so movement 1 is reflect with respect to the x-axis. So if we do that, let's reflect. So clearly what we should have, this is what we should have. So this is the reflect with respect to the x-axis, right? Okay, and then, so this is the reflect. And then reflect with respect to the y-axis, right? So it's reflect in the y-axis. So reflect with the y-axis. So let's reflect it. All right, so this shall be the final position of this triangle after these 2 refractions. So if we look at these 5 pictures, this is the one, D is the one that what we want, right? Problem number 5. So here we have 100 numbers from 0 all the way to 99. Okay, so what Andrew did is he added the digits of those numbers together. And the goal is to find the average of the sum, right? Okay. So for this problem, we have 2 ways to solve it. One way is kind of, which is straightforward, which is sort of a brute force. So basically, we literally add all those numbers together, and we divide by 100, find the average. Okay, so method 1. Which I call straightforward. Okay, so it's kind of brute force. All right, so we start from it's 1, 2, 3, all the way to 9, and then 10, 11, 12, all the way to 19, and then it's 20, 21, 22, to 29, all the way to 90, 91, 92, and to 99. All right, so we add all those digits together. So this is 0 plus 1 plus 2 to 9. So this is, we know it's 45, right? 45. Okay, so here, okay, so next one is we have all the ones. So that's 1 times 10 plus 0 plus 1 plus 2 and total 9. So this is 10 plus 1 plus 45, right? So this is what we have. And the next one is 2 times 10 and plus 0 plus 1 plus 2 to 9. So 10 times 2 plus 45, right? Okay, so all the way to 9. So this would be 9 times 10 plus 0 plus 1 plus 2 all the way to 9. So this is 10 times 9 and plus 45. Okay, so the sum, so the total sum, so this is the total sum equals, we just add all those together, right? So let's see what we have. So what we have is this is 10 times 1 plus 2 and all the way to 9. And then plus 45 times 10, right? Times 10. Okay, so what do we have? This is just 10 times 45, and plus 45 times 10, which is 900, right? Which is 900. Okay, so the total sum is 900. And then we get the average, right? So we say, okay, so now, so the average equals 900 divided by 9, which is 100, right? So this is the first method, which is based on straightforward calculation. Now let's look at method 2. So method 2 is a shortcut, which is kind of a Gauss trick when you calculate the sum of 1 all the way to from 1 to 100. So let's look at method 2. I'm going to erase that. So this is method 1. Let me erase this. All right. Okay, so method 2. Let's list out this 100 number. So we start from 1, which means the sum of digits, right? The sum of digits. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 is 1, and then it's then 11 is 2, and all the way to 99. We know this together is 18, right? So we have 18 and 17, right? So in total, this is 100 numbers. All right. Now, if you look at those numbers, you find 0 to this one. This is 18, and 1 to 17. This is also 18, right? And we expect the 2 goes to the next one. This is 15, which sorry, this is 16. So we have also 18. So we basically get like pairs of 18s, right? So then we can say, okay, so what we have, so from here, what we get, the total sum is what? It's 18 times how many pairs we have, times 50, and then divided by 100, which is 9, right? Which is 9. Okay, so I want to say a little bit like why we have this kind of pattern. So the basic mechanism is, so here the reason is, you think of 2-digit number AB, right? So this is 2-digit number AB. Now, if I look at 99 minus AB, what would we get? Well, it's just 9 minus A. So this is the first digit. And the second digit is just the 9 minus B, right? 9 minus B. Let me write clearly. So it's 9 minus B, right? Of course, you can also consider A as, you can take A 0, then it becomes a 1-digit number, right? All right, okay. So then you see, so the sum of digits is the sum of digits. So this is just A plus B, right? So this is A plus B. And this guy's 9 minus A plus 9 minus B. If you add them together, you see what do you get? You get AB cancel with AB, you get is 18. So this is why you get the pair if you do algebraically. Right? So my point is, basically, if you look at 2 numbers, if their sum is 99, then when you add them together, well, if the sum is 99, so then the sum of digits, you add them together will be 18. Now let's look at number 6. So number 6, so here we have a very special arrangement of numbers, which is so-called the Pascal Triangle in math literature. So in Chinese literature, sometimes it's also called a Yifeng Triangle. So this is named after Asian Chinese mathematician named Yang Hui. He lived in Song Dynasty, which is around 1280. All right, so you see, if you look at numbers on this triangular arrangement, so the first number, the top number is 1. And then when you go down, each number is the sum of the number that is on the left and on the right, right? Okay, so this problem asks about, let's say we add the numbers on each row. Okay, so then if the sum is 250, the question is, which row is that, right? Now, what we're going to do is let's add the numbers on the first several rows and try to find the pattern, right? Okay, so solution. Let's find the pattern. So what the first one is 1, right? So that's nothing to do. And this is 1 plus 1, which is 2. And this is 1 plus 2 plus, so we look at the sum. So 1 plus 2 plus, so this is 4, and this is 8. This one is 16, and this one is 32. And then we say, okay, it looks like there's a pattern. The pattern is each time you multiply by 2. So from here, I can rewrite. So if I can rewrite this as equals 2 to the power 0, right, which is 1. And this is 2 to the power 1. This is 2 to the power 2. And this is 2 to the power 3. And this is 2 to the power 4. And this is 2 to the power 5. And those numbers 0, 1, 2, 3, 4. And this is the rows, right? So this is the row 1, row 2, row 3, row 4, and row 5, right? All right, so then we say, okay, based on this pattern, we say what we get is, we are basically looking for what is the power, the 2 to the power equals 256, right? If you memorize those special numbers, like 2 to the power 10 is 10,024, and then you reduce by 4, you get, okay, what is this? So this is 2 to the 8. It's the product of 8 twos. Another way to see is if you say, okay, what's this? This is just 16 times 16, right? So what's 16? So 16 is, this is 2 to the 4, and this is 2 to the 4, so we get this 2 to the 8. So from here, we get the question mark. This one is 8, so it's on the 8th row. All right. Okay, so we get the answer by looking at the pattern of sums on each rows. Now, I want to say a little bit more about this Pascal triangle. So what is it's really for? All right. So if I look at, so here I'm going to look at this. So if I look at the A, so this is some algebra. So if I look at A plus B, right? And I look at the coefficient, so this is 1 and 1, right? Now, if I look at A plus B squared, so what do we have? So this is A squared plus 2AB plus B squared. So I get is 1, 2, 1, right? Now, if I do A plus B cubed, which is just A plus B, right? Which is A plus B squared times A plus B. Now, if you write out, you get this is A cubed plus 3A squared B plus this is 4A 3AB squared and plus, and this is the B cubed. Okay, so what you get is 1, 3, 3, 1, right? So my point is, this is how it's related to the Pascal triangle. So Pascal triangle, so this is the 1, 1, right? So you get this is 1, 1, which is the coefficient of here, 1, 1, and then 1, 2, 1, 1, 3, 3, 1, right? So this is what you have. This is row 1, and this is the row 2, and this is the row 3. So basically, if it for the row n, what you do is A plus B to the power n, and then you write out, you have all those coefficients. So row n is the coefficients of the expansion of A plus B to the power n. So my point is, like, if you A plus B to the power n, if you write out and you collect all those coefficients, like what we did here, and what you're going to get is the numbers on the row n of of this Pascal triangle. So this is the important application of the Pascal triangle, right? Give you a quick way to figure out those coefficients. All right. Okay, so in particular, you see, if you let this one to be 1, this one to be 1, then what you get is just 2 to the power n. So that's what we have, right? Problem number 7. So this problem says we have 2 people, John and Dieter. Each of them tells truth on Sundays and lies on the other days, while they have different patterns. Say one day, both of them said, yesterday I lied. The question is, what day is that? All right, so for this kind of problem, a very helpful approach is to draw a picture, draw a table. Let's say we draw a table. Just to mark like on which days each of them lies or tells the truth. So here we have, this is the Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Okay, so here we have John and Dieter. Now I'm using these 2 means telling the truth, and this means lies. Okay, all right. So let me put those marks. John, he tells the truth on Monday, Tuesday, Wednesday, and Thursday, and lies on the other days, right? For the other guy, Dieter, he tells the truth on Monday, Friday, Saturday, Sunday, and lies on the other days. So this is the picture what we have. Okay. Suppose on one day, someone says, yesterday I lied. Okay. Says this, yesterday I lied. So yesterday I lied. Now suppose this is the day right here, and this is the day that's before it. So this is today, and this is yesterday. Okay. Now think of this. Now, for this, in order for this to happen, for these 2 days, so here we have 2 days, right? So they cannot, for the 2 days, they cannot both lie or they both tell truth. So this is what we have, cannot. So we conclude, cannot both lie or both tell the truth. Tell the truth. In other words, we cannot have things like this or things like this. So these 2 scenarios are impossible. Impossible. Now, why is that? Well, you think of this. If we have things like this, today he tells the truth, and yesterday he also told the truth, then he says, yesterday I lied. Well, if we choose, then it means yesterday he should lie. Well, that's impossible, right? So this is impossible. So impossible. If it's both days that he lied, then it's okay. Today he lied. Yesterday I lied. Because it's a lie, so yesterday he should tell the truth, but yesterday he lied. So this is also impossible. So this is what I mean. We quickly conclude it cannot happen, like say this is today, and that's yes. It cannot happen on 2 days, so that he either both lied on the 2 days or both tells the truth on the 2 days. Okay. Now, if you look at what we have here, you see the only time, let's say for John, then the only 2 days which we do not have 2 clause or 2 this right sign, then only what we have is right here. That's the only possible case, right? So we have these two days. If you, for Dieter, he could have more options like right here, or you could also here. But if you combine, that's the common way that works for both of them, right? So that's the common combination that works for both of them. Then you see, if I combine, clearly you get it's Friday. So Friday is the day that both of them could say, yesterday I lied, and still inconsistent with the given rules. All right, so the question is Friday. So the answer is Friday.